Okay, so now this is the video on trigonometry when you need to find an unknown angle. Make sure that you've actually viewed the first part of this video series, trigonometry finding an unknown side. In that video, I actually go through labeling the triangle, applications of trigonometry, SOHCAHTOA, strategies for solving. So please make sure you've actually seen that one first so that you understand what's happening in this one. Okay, so basically, this time we're going to look at finding an angle, and we're still going to be using the same basic ideals. So just for an easy fluency problem, I've got a triangle here. I have an unknown angle given up here at B. I do have side A, it's 3 centimeters, and side B, which is 4 centimeters. I do not have side C, the hypotenuse, that's an unknown. So basically, I still start by going SOHCAHTOA and deciding what I've got. Now, I need to find the angle. So my S, C, and T will be dots because that's what I'm trying to find. I have got, let's have a look. This side is opposite. This is the hypotenuse because it's the longer side, which makes this one adjacent. So I've got adjacent and I've got opposite. So I've got opposite, opposite, I've got adjacent, adjacent. I do not have the hypotenuse. So the only one that has 2 ticks and a dot is tan. So I write my rule. So that's tan of the unknown angle is going to be opposite over adjacent. Now, I do not know the angle, so it stays as an unknown. I do know opposite. Opposite is 4 centimeters and adjacent is 3. Now, in order to get this unknown little Greek symbol here all on its own, what I need is I need to get rid of tan. Now, what I have to do for that is I need to do the inverse. Okay, so the inverse of tan, you'll see on your calculator, is tan to the -1. Okay, and what that means is I'm basically putting 1 over tan. Okay, and I can write it this way. The inverse. So if you look on your calculator, your tan button, above the tan button, it should have tan to the -1. That's the inverse, or the opposite. And then I just put my 4 over 3 in brackets over to the side. Then I just pop that straight into my calculator. So tan, inverse of tan, and then I put in my brackets 4 over 3. And what I end up with is 53.13, kind of continues, so I can just go 53.13 degrees, thereabouts. Okay, and that's straight up my calculation for a fluency finding an angle problem. Now, what I really want to look at is word questions. So I'm just going to pop a word question up and then we'll run through that. Okay, so we've got a playground slide made up of a ladder and a metal slide. The top of the metal slide is 2.2 meters from the ground, and the bottom of the slide is 4.8 meters from the point directly under the top of the slide. What angle does the slide make with the ground? Okay, so the first thing we're going to do is draw a diagram. Definitely. Let's have a look at what I've got. I've got a slide. So here's my metal slide. Here's my ground. Okay, metal slide. Now I'm going to have a ladder, but of course the ladder is going to be, let's just do that so it indicates a ladder. It's of course going to be at a slight angle so the kids can actually climb up it. This is the point, they talk about the point directly under the top of the slide. That's the point directly under the top of the slide. That makes a right angle with the ground. Now I have been told that the top of the metal slide is 2.2 meters from the ground. So that means that this distance is 2.2 meters. And the bottom, so that's down here, is 4.8 meters from the point directly under the top. So from here to the bottom, 4.8 meters. What angle does the slide make with the ground. That's this bit here. There's the ground, there's the slide. This is the slide here. That's the ladder. So this is the unknown angle here. So what I'll do is I'll draw an actual triangle and label it like we've done before. So it's a right angle. This is 4.8 meters. This is my unknown angle, and this is 2.2 meters. Now from there, I can actually label it. If this is my angle, this is my opposite side, this is my hypotenuse, and this is my adjacent side. Okay, and last of all, I can work out what it is that the angle of the slide makes with the ground. So, SOHCAHTOA. Now, I need to find the angle. Find the angle, find the angle, find the angle. I have adjacent and opposite. They're the two that I've got. So, opposite, adjacent, opposite, adjacent. I do not have hypotenuse. So, I am once again going to be using tan or tangent. So, I write my formula. Tan of unknown angle is equal to opposite over adjacent. So I still don't know what my angle is, but I know that my opposite is 2.2 and my adjacent is 4.8. So in order to get the unknown angle on its own, I do the inverse of tan, so tan to the -1, and that's the same for cosine or sine. It'll be cosine to the -1 and sine to the -1. Just have a look on your calculator. And I place my fraction in brackets. So some calculators, it's really important that you actually do that. So just be wary of that. So what I will actually find is I get 24.6236, and it continues. And if I could do it directly underneath, I would. So I'll just do it over here. My approximately equal to, I'm going to round that to 25 degrees. So then I can write my therefore statement. Therefore, the slide, the metal slide, makes an angle of approximately 25 degrees with the ground. So it's on a 25-degree incline, okay, as it goes up. Okay, decline would be down. Remembering that as we go through all this, okay, so we're getting M1 for our diagrams here, we're getting C1, C2 for organisation presentation using correct units and labelling techniques. You would get C3, transferring information from the word problem correctly into diagram and then formula, algebraic form. Then down here you would end up with your K1, your K2, all the way down. You'd get K3 down here for calculating correctly, as long as your calculator's in degrees, and just C1 for rounding correctly here. And then of course you'd get M3 for the therefore statement that I just gave you verbally. Okay, so please make sure that you are confident in being able to break down particularly a word problem and apply trigonometric ratios in order to solve that problem.